Okay, in this video we're going to do some more examples of JavaScript, this lecture here, using mostly what we know, giving some practice using conditions, loops, and functions. There's a list here of some examples that we can try. We'll start with this one. And all of these programs are going to take arguments like we did in the last lecture. We'll go into the class directory. And we have JavaScript Basics and JavaScript Terminal, and we'll make a JavaScript more examples. Okay, so we're going to go into JavaScript more examples. Okay, and we will take one of our examples from the last lecture as a starting point. We'll take the convert C. And I'm going to call this convert check. So as it is, it'll just do what we had before. It expects one parameter, which is the temperature in Fahrenheit, and then if it's not there, then this length will be less than 3. There's always going to be node and the name of the program, and then if there's any arguments, the length of the number of arguments would be at least 3. So if there is an argument, then we take that as a float and do the conversion. Alright, so that's what it does now. Let's just make sure that it still works. So that's what it said before, and if we give it a Fahrenheit temperature like 32, converts it to Celsius. So now the idea is the usage will be something like node convert check.js, and we'll give a Fahrenheit temperature and a Celsius temperature, and then the program should say whether the conversion is correct. So for example, they might say node convert check.js 32 and 0, and should say correct. And if they give something wrong, node convert check.js, let's say they switch it around, should say incorrect, or something like that. Alright, so now you could look at the program, take a pause, and what's going to need to change so that this is what we do. We still have the conversion function available to us. What else has to change? Okay, so one thing that changes is that we're taking 2 arguments instead of 1, which means this length we expect to be at least 4. I'm going to change the usage statement to be convert check, and why don't we call this degrees F and degrees C. Okay, so we expect to take 4 arguments instead of 3. The general philosophy with the programs is you want to test it as often as possible. So if I run it right now, what should happen? I'm checking for having at least 2 arguments, and then after that it'll do the same thing as before. So if I run it like this, it should give an error because now it's wanting 2 extra arguments. And there's the usage statement. Right now it's still just converting this one and printing the result. So it doesn't do what I want it to yet, but at least that part works. Alright, so now down here we're going to need to get 2 arguments and not just 1. So I'll call this one degrees F. It should be the first one. And the second one should be degrees C. We can keep this conversion function the way it was. And what I want to check is, say, the correct degrees C is doing the conversion. So that would be the correct answer. So the correct conversion. And we want to check whether that matches what they gave us. So we want some kind of an if test. And this is our general structure for doing an if and else. So we're going to have some condition here inside the parentheses. And maybe I want to say here console.log correct. And here I'll say console.log incorrect. Okay, here we would say incorrect. And this is not going to be there anymore. Okay, so now we want a condition here that says they had the correct conversion. So we have available to us correct degree C and also degree C that they claimed. Those are the two things that we have, and we want to check whether they're equal. So to get started, you could say is equal to, that's not JavaScript code, but it's pseudocode, and then you want to turn that into JavaScript. If you forget, you search online. Also, you can go to our notes here of JavaScript basics. Here are the comparison operators. There's equal, equal, and that's what you use to check if two things are equal. And I'll put a note here. Let's see. Syntax errors. On the bottom here, no, let's say it's important enough. Do not use equal for checking equality. Equal just by itself is an assignment. So it saves a value into a variable. There's a note there on the variable. Okay, so we would want here equal, equal. That tests if they're the same. And I will note already, what if they're close but not exact? We can decide what to do about that in a second. So let's just check this out. First, let's run it with no arguments again. Make sure that still does what it's supposed to. Gives the usage statement. Okay, now let's give one that's correct. 32 Fahrenheit is 0 Celsius. It says correct. If we get them switched, 0 Fahrenheit and 32 Celsius, it says it's wrong. What if we do 212 and 100? That says it's correct. What if we do, let's see, 98.6 and 37? That's human body temperature, roughly. It says they're correct. Negative 40 is the same for both. Okay, so that's pretty good. The only other thing is, what if our conversion is very close to being correct? So let's go back and look at, this was from the if, one of the ifs, I believe. No, function. Right, so what are some of the other ones we did? 98.6, 100, 90, 72. So we might remember that, let's say convert 72F to C. So we might remember 22.2. So if we run this with 72 and 22.2, what's it going to say? It says incorrect. It looks like I misspelled incorrect there, but okay. 72 and 22 point whatever, let's see, Google said 222. That still says incorrect. because it's because of the way the computer, let's see, this is a repeating decimal, and we can't actually store an infinite repeating decimal. So if they're correct except for a very small error, then maybe we want to do something else. So we might want a different message for off by a very small amount. Could be correct up to the precision of the numbers. The numbers are not stored infinitely precise. So if it's very close, correct degree C, and we have degree C, it should be the case that if we subtract them, it'll be relatively small. So we could say that this is less than 0.01 and degree C minus correct degree C is less than 0.01. So if that's the case, that's the same as saying that they're within 0.01 of each other. And we could change that 0.01 to be 0.1. We could say correct within, maybe we want to make that an option that we could easily change. Var tolerance equals 0. Why don't we give it 0.1 instead of 0.01. So here we'll say tolerance and let's see if that works now. Correct within 0.01 of tolerance. And if they're incorrect, maybe we should tell them actually we could say degrees. Okay, so actually degrees F equals correct degree C, and we should put a F here. Let's see, maybe we'll do this one here, which had the incorrect. So then 0 degrees F is actually negative 17.7 repeating Celsius. And we can check this one again to make sure it still works. This one should say it's correct within 0.1 now. Yep. Okay, so that's that example where we have another if test. So the operators, the things that we have available inside an if test, we can compare whether two things are equal. We can compare whether they're less than. We can also use greater than, less than or equal to. This is not equal to. So maybe we want to, let's see what else we have. Well, okay, so that's not equal to. And then we can put them together with and, with or, and with not. The exclamation point there is not. So as another example that tests those, I'll do operators.js. And what we'll do here, this is my vision for this one. Operators.js, and then I'll have num1, and then operator num2. Should give the result of doing the operation. So examples here. What I'm having in mind is operators, and then we might do something like 5 plus 6, and that should give us 11. And operators.js, let's say 6 less or equal to 5, and that should say something like false, or possibly 0, because 0 is the same as false in programming. Something that we'll have to do, because some of these operators have special meaning in the terminal as well, not just in JavaScript. Is put quotes around the operator. So when we run it, some of the operators are okay in the terminal and they don't have a special meaning, other ones do. So we'll do it like this, where the numbers are okay on their own, but if we want to pass the text of an operator like that into the program, we have to put quotes around it. And now, how many arguments are we going to expect? What's the length of this argv going to be? We have 1, 2, 3, 4, 5. So that's going to be our usage statement. And this one is called operators. And we can print the usage, num1, operator num2, and we want to tell them that there should be quotes. If you look at the way that this is doing the syntax highlighting, there's something here. I have begin quote here, end quote here. So the JavaScript program would think that this is the end of my string, and that then this is the name of a variable because it's outside of the quotes. So if I want to actually print a double quote, then I put a slash, and that tells it that I want to print the double quote and not use it to end the string. Let's just check to see if that's on our list. I don't think so. It's a common thing that's called escape characters. This happens in pretty much most programming languages. To print a double quote inside of a string, use slash double quote. To print a slash, use slash slash. Other escape characters are /n for new line, /t for tab, and there are others, but those are the ones that we would normally use. Okay, so that would be our usage statement, and so the next part is always to grab the parameters. So I'll use the same names in my program as I was using here in the usage statement. The first one is called num1. Num2 is going to be the third one. It's going to be, let's see, the operator's in the middle. And our operator is not going to, we're not going to interpret that as a float. We're just going to say process.argv bracket 3. And I'm going to go ahead and wipe everything out and just print the parameters just to make sure we're getting them. Num1 operator plus num2. And let's see if we're at least getting that part right. Okay, there's our usage statement for not giving enough operators, and if we want to do 5 plus 5, it says input is 5 plus 5. Now something non-trivial is happening here. The plus, when you have numbers, it will add the numbers, but if you have a string, so here's a string, text, and I have plus a number, so what's it going to do? And what JavaScript decides to do is if either side is a string, it'll treat them both as strings. So it converts this to text and adds them, so then this whole thing would be a string or text, and then we add on more text, so then this whole part would be text or a string. There's a number, we have a number plus a string, it's a string, and for printing it out, that's fine, that's what we wanted. Alright, now we want to actually evaluate it. And so we're going to have to do different things depending on what this operator is. Just to give another use of a function, we'll have a function here, do operation. And this is the way it always is. You have some statements, function. So the keyword function, the name of the function, parenthesis, curly braces, and then inside is what actually happens, and then we would have something like do operation here. So we could say console.log hello, just as a starting point. So there's the hello message. Okay, but what I have in mind is that I could do the operation like this, num1 operator num2. So I would like to call it like that. In order to do that, these values need to get passed into the inside of the function. That's the way we think of this. This is some process that we define that can be ready to go, and then when you're going to use it, you pass in something. So in here we need to give names to variables that will come in, and these could be something different. So this would be the order of operations here as this all runs. When you get to the function definition, it says okay. I'm reading in that function definition and just saving it for later for when it's needed. And then when we get to this line, it's going to run the function, and the order of operations is these values get copied in up here. Num1, the value of num1 gets copied into a variable called n1. Operator gets copied into a variable called op. Num2 gets copied into a variable called n2. And then this all runs. Okay, so I could print those values right now, but I'm going to skip that. We're going to do something with the op. So I want to say if op equals plus. And if it equals plus, then I should do n1 plus n2. I'll say result. Okay, and then I'll have an else here that says result equals unknown operation. Okay, so either the result is going to be a number that we do adding these up, or it's going to be a string that says unknown operation, and then I'm going to return the result. Okay, so now these values get copied into these variables. This code runs. When the return statement happens, this result gets sent back as the value of the function. if I want to do something with it, I have to save it. I'll call it capital R for something. So the function runs, a result gets returned. That's the value that's sitting here. That'll get saved into this variable R. So now I could print it. Let's try to see whether we have some mistakes. So it says 5 plus 5, and the result is undefined. Which means we need to do some more printing. So let's say we print here console.log result, and this is the process of, that's not the behavior I expected. I expected to see 10 as the answer, but it says undefined instead. So I'm going to go and print something somewhere. I think this should be 10, but we'll see what it prints. Okay, there's undefined right there. Okay, I would go up to, I think this should be happening right here. You might already see what the problem is, but I think this should be happening because I put a plus in. So the result here should be 10. Still says undefined. Then I look at this line. And hopefully I noticed that I had a mistype here. And that's what's happening. So I could go ahead and fix that mistype and let it run. I should see the value 10 printed there, if that's the only mistake. Okay, there's 10. So this should go as a warning in our JavaScript notes. Variables, warning, variables do not have to be declared. If you mistype a variable name, JavaScript, a variable name in an assignment, JavaScript creates a new one. So we're normally doing these by declaring them as var. If you don't have a var there, creates a new one that is global. Alright, so at this point you might want to do some reading. Let's go over to the W3 schools. I'll just point you to the information about this. Okay, so this would go under the category of strict mode. So if we have use strict at the very beginning of our program, then what that does is it turns off some automatic things like this. Note, if in strict mode this doesn't happen, we'd get an error like we would hope. So we would probably want to put under here best practices for JavaScript. Put use strict as top line in the file. And let's see if I had that error again. Result. So then instead of running, it gives us an error message. And the error message says reference error, result is not defined. It prints right here where it was, line 29 in my file. So you should read that error, go to line 29, which is right here. If you're using Emacs or Vim, it'll show the line number. And the rest of this here, what it's showing is how it got there. So it's inside of the do operation function, which came from running the file, which came from, this is how Node was running. So most of this doesn't really mean anything to you, but the topmost thing is where it was when it had the error. Okay, so in general, we're going to use strict in all of our files to make it less likely that we make a mistake like that. Okay, and we'll put a note here. We are in this lecture, and we also note on use strict and escape characters. And there's a reading assignment for strict mode. Let's see if there was anything else for you to look at. Really, a lot of this stuff would be good to look at, but we'll leave it as that for now. Okay, so if we wanted to have more operations here, we would have else if here. We could just add in more. So if we want to see op equals, say, minus result equals n1 minus n2. There's that. Now if we put something that we haven't defined yet, what's it going to print? Unknown operation, which is correct. So we could put in here, could also put in anything that's a binary operator. So star slash any binary operator. Binary means takes two numbers. We'll add another one that's sort of counterintuitive as ampersand, which is and, just to see what it does. So it's supposed to mean and in an if test. But if we give it numbers, what do you think happens? So what if we do like this, 1 and 1? It printed 1. About 1 and 0. 0. About 0 and 0. So what it's doing here is it's taking the 1 and interpreting that to mean true. So true and true. So the and is going to be true if both parts are true. And a 1 means true. So true and true gives true. True and false. They're not both true, so it gives a 0. And that goes in our notes under Boolean operators. So note for and we have we get true if both are true. So let's say A and B is true if both A and B are true. We could try or. Or is 2 vertical bars. What if we say 1 or 0? The definition for or, well, so we don't have that defined yet. Okay, so if we put that in, what it should be the case, for A or B is true if either A or B is true, or both. And not A is true if A is false. It just flips it. Alright, so those are the Boolean operators, which we could even put in numbers. Let's see, node operators. Say we say 5 and 4, say. What does that do? It gives 4. Let's try 5 and 8. It gave 8. So it seems to be giving the second one according to those examples, but let's do 5 and 0. Okay, so what it's actually doing is if they're integers, then not 0, anything other than 0 is considered to be true, and it seems to be giving, if they're both not 0, it's returning the second one. So if that's true, what should this give? Give 0. So if either one of them is 0, it gives 0, false. And if both of them are not 0, it gives the second one. And I'll say, so note in programming, 0 is false, 1 is true, and anything that is not 0 is often considered as true as well. Strange, but true. Okay, so there's an example with a function. We define the function with the keyword function, name of the function, list of variables that will come as inputs. When we call the function, we have the same name as we used in the function definition. You have a list of some numbers or whatever that go in. They get copied into the variables. The code runs. If there's a return statement, the function's done. It sends back whatever that value is. And if we want to save it, we need a equal, an assignment. Okay, so that's an example. Let's see how we're doing on time. That's about it for time, so we need to stop. Let's see. So here we have, so we've done conditions and functions. And we're going to have to do a separate one for loops. Conditions and functions. Some more examples using what we know. We did unit conversion checker. So unit conversion checker and evaluating binary operators. We also introduced use strict and escape characters. So we'll do some of the rest of that using what we know. SEArt, addition table, roll dice until value. And then we'll have a lab assignment after both of those are done. Alright, let's say that's it for now. 40 minutes is enough. Okay, one more thing for the quiz. This is, I'm calling this condition function examples. Condition function examples. question will be tomorrow and tomorrow and tomorrow. The answer will be ... is the tale told by an idiot ... That's from Macbeth. Look up it's a famous part of Macbeth. You look it up if you want. That would be the answer to the quiz.